Hello, somebody found an error in my lecture. mv squared over r at the equator for a 60 kilogram person is 2.02 newtons, not 0.32 newtons. Doesn't change the conclusions, but it's a good error to catch. As an aside, if you look up the centripetal acceleration of the Earth at the equator, you get 0.0339 meters per second squared, which is slightly different. I think if you plug into this equation, you get 0.0336 or something like that. But anyway, there's actual real differences if you make the real measurement. But in any case, we did an ideal measurement. We were pretty close to the real difference. But what I want to show is that 0.0339 meters per second squared is still pretty small compared to 9.8 meters per second squared. So it doesn't make a huge difference, but it is a 0.3%. If you look at that, it's 0.3% error. 0.3% difference is not an error. Okay, going back to my error, I said 0.32 newtons. It is actually 2.02 newtons. This is MA, right? So this is just multiplying these acceleration values by your mass. If your mass is 60 kilograms and therefore your weight is approximately 600 newtons, then 2.02 newtons is still a pretty small change, but is definitely a noticeable change when you, hold on. There, I wrote that better. When you make careful measurements, if you were making careful measurements, it would be something certainly noticeable. But it's not like you're going to feel like you lost weight because you go to the equator or you go somewhere where the Earth is rotating a little faster.